And hello, welcome to this video of again networking. Excuse me. Yep. So yeah, we went through non-routable address space the last time, and that's where we left off. We also went through a very simple example of two networks connected via a router, and sort of the process of what happens when the Ethernet frame, how the Ethernet frame is roughly constructed. Okay, I simplified a lot of things, and yeah, I explained how this data packet goes from this IP address to the router, which is probably at another IP address, and the router sends the data to the destination computer. So that's how the connection is done. Of course, I simplified a lot of things. I didn't only mention addresses over here, so I simplified it by excluding something called a TTL field, a time to live field for the IP datagram. That's called a time to live field, but I kind of excluded that because that might complicate things, so I just ignore the effect of the TTL field. Okay, so so far this is the rough gist of how one computer talks to another over on another network via this router. Of course, the internet isn't that simple. You have to scale this up a lot, and yeah, what does the picture look like? Okay, so yeah, what does the picture look like at if it's upscaled? Okay, so routers on large scale, or routers in the large scale. So how does it look like? Okay, so let's say you have one network here, one router here. Okay, the routers, I like to use triangles, and this router will be connected to another network. Okay, this router will be connected to another network, and this network will be connected to another router. Okay, so for simplicity, I'm not going to draw all the networks in between. I'm just going to draw a line there. But just know that one router is not necessarily connected to another router just like that. There may be other networks other computers connected along this network, which is represented by a line. Okay, and in reality, the internet is linked up by many routers. Okay, you can have this whole network like that, and I guess the biggest reason why a router is called a router is because it helps to plan the route for your data to go from point A to point B, right? Why do we talk about routes? Because on the internet, where all the routers are sort of connected to each other, all right, there are many ways or many routes that your data can can travel from point A to point B. So in point A, you can actually go through this route, which is the most straightforward and shortest route. Or if somehow this router is kaput, or it is broken, or there's some earthquake that kills this router or the connections here, the internet can still or the routers can actually reroute their traffic via another path or another route, like what I'm drawing over here. So that's what a router does. So there is some level of redundancy. Of course, this means that there must be some sort of algorithm to help determine how these routes are formed, and this is actually under the topic of routing tables. Okay, routing tables. Now, for the layman, you don't really need to know what routing tables are. Just know that there is excuse me. Yeah, just know that there is a algorithm to help decide what route is the fastest and most reliable. Okay, so this is about 440. Yeah, routing tables are algorithms which the routers will Well, or rather, let me put it this way. A router will have routing tables to sort of decide what is the best path for a data packet to travel from point A to point B. Yeah, and so routing tables are the best, are the way that these routers store the data so that they know which adjacent router to kind of forward the traffic to. Okay, and how these routing tables are designed, this is another topic for kind of out of scope for the layman. So I won't be going into detail. So you can imagine the internet as sort of a web of routers. That's why we like to call it the World Wide Web, and they have lots of interconnected routers working together. Now, of course, each of these lines may not just indicate a direct connection. There may be some computers that are actually connected to these lines, or these lines may actually may consist of a network. And don't just think that each network can only have two routers. Each network can have multiple routers to it. Yeah, it's really up to the internet, up to you and up to the internet service providers to actually decide how many routers there are to their network. Okay, so so this is like a slightly more realistic picture of the internet, and not something so simple like that where you have two networks connected by one single router. So in fact, you have a huge network connected by several routers, and with that, I want to talk about I want to come back to the topic of how we are able to so-called share IP addresses, right? So remember I said we can share IP addresses, especially in this non-routable address space. So how is it being done on the internet? So let me illustrate with an example. Okay. So sharing IP address spaces. So let's begin. So let's say you have a network A with a computer here and a router, and then let me use let's call this network B. Again, another router, another computer. Okay, and this example is actually let's see. I think I close the tab. Should be network address translation on gigs for gigs. Yeah. So let's use this example which you see here. Network address translation for inside and outside addresses. So I'm going to use this example here just to give credit where credit is due. Okay, so let's start. We'll have one private network A and one private network B, and let's say your computer on network A has this IP address 192.168.76. Yeah. Okay, and then this computer on network B also has this IP address 192.168.76. Okay, let me try moving it around. Oh, I moved the wrong thing around. Okay, never mind. That didn't work as well as I wanted, but let me delete this. Okay, let's try again. 192.168.76. And then I'm going to use sort of this cyan circle to just represent the complicated layer of routers on the internet. Okay, so how are you going to send a packet from 192.168.76 to this IP address here, 192.168.76? Are you just going to craft the IP datagram 192.168.76 to 192.168.76, you'll probably just send the datagram, the IP datagram back to yourself. Okay, that doesn't quite work like that. So with that in mind, how then do you send? How then do you properly craft this IP datagram? Okay, remember IP datagram is supposed to contain the source IP address and the destination IP address, along with all the data that's encapsulated inside this thing. Just like the MAC, the Ethernet frame is supposed to contain the source MAC and the final MAC address. Okay, so how are you going to craft this IP datagram? Okay, we know the source IP address will be definitely 192.168.76 on network A. Okay, but the destination IP, okay, clearly cannot be this IP address, right? Cannot be this IP address. So what do? Okay, so the short answer is that we don't use this IP address here in our IP datagram. Okay, instead we use the IP address of this router. So let's just give a random IP address 12.1.1.1, and let's call this router address 12.1.2.1. Okay, I might confuse myself later on, but let's hope I don't. So in your IP datagram, your source IP address will be as follows. Okay, source IP 192.168.76, destination IP 192.168, or no, 12.1.1.1. So this is the IP datagram info. So that's what we are doing here. So we'll have the source is this, destination is this. Okay, so let's just picture this with me for a while. Okay, picture this with me. So the IP datagram will be such that it sends from this address to this address, and along all the routers on the way, there will be the changes to the Ethernet MAC address along the way. As you know, routers always like to change the Ethernet frames, so they will just make their zigzag through the internet until it reaches here. Okay, so let's say for the sake of example that part is done. Now this data packet arrives at the router. Okay, what is this router going to do? Okay, the router will examine the IP address and say, hey, the IP address, the destination IP address is my address, and the source address is, okay, this address. Okay, then what am I going to do now? Right? So this is something where there's additional info needed. Okay, additional information is needed to do network address translation properly. Okay. Okay, and also one more thing, I forgot to say this. There was one thing I was missing in that prior example. The source IP address will not always stay 192.168.76. All right. I think I forgot to mention this. Okay, so let's do some correction. Okay. So this is what the IP datagram looks like when it leaves your PC. It leaves your PC at 192.168.76 and goes to the router. Okay, router. Okay, once it arrives at the router, what does the router do? Okay, the router says, okay, the source. Okay, the source is 192.168.76. Destination is 12.1.1.1. Okay, the router not only changes the Ethernet frame, that means it not only changes the Ethernet addresses, that are encapsulated in the Ethernet frame. What a router does when it does network address translation is that it will change the source. It will change the source IP address as well. So instead of the source IP address looking like it came from your computer, or looking like it came from this computer 192.168.76, the router will instead change it to its own IP address, 12.1.2.1. So what network address translation does to kind of save the IP space, okay, it will change the source directory. It will change the IP datagram such that the source looks like it comes from the router. Source, wait, one more time. Source 12.1.2.1. So where's the source coming from? Okay, it will come from this router here. So what network address translation does is that you will, when your data packet travels through the internet, your IP address on the local network will be hidden. No one will ever see this IP address unless you choose to like reveal it elsewhere. But in the IP datagram, you will only see the destination IP address and the source IP address of what do you call that? Of your router. Okay, so this is what we call the public IP address, right? Public IP address. So if you can go and look at Google, or you go and Google what your public IP address is, and it will be different from your private IP address. When you type IP config on Windows or IPA on Linux, you'll be looking at your private IP address. But your public IP address will be different. It will be the IP address perhaps of the router or at your internet service provider. So this is what happens. Okay, and when it comes to the router here, the router here will do another. It will also do another. It will change the IP frame as well. IP datagram. Sorry, IP datagram. So at router 12.1.2.1, the source will become 12.1.1.1. Destination becomes 192.168.7.6. Okay, this is the eventuality. Okay, I haven't addressed how this is being done yet, because the original message contained no data. As far as we have discussed, we have not discussed that the message. Excuse me. We have not discussed any additional information that's needed to do the network address translation. So how do we know that the destination IP address is 192.168.7.6 as shown over here? Alright, we don't know yet. So the way this is done is not through guesswork. There is a specific way that you tell the router here to forward that data to this IP address, and that has to So okay, let me clarify again one more time. Network address translation, okay, is the bit where we actually change the source and destination IP. Okay, changes the source and destination IP address at the router. Okay, it's not equivalent, but changing the source and destination IP at the router is definitely part of the network address translation process. So this is a very, very loose definition or association that we can give. So if the source and IP address doesn't change, there is no network address translation. But when the source and IP destination, or when the source and destination IP address change at the router, this will be when network address translation is taking place. Of course, this is actually a very broad it's a broader concept than just the source and IP destination changing. But I won't go that much into detail. So this is like half the story of how IP address space is being saved, where we keep changing the IP addresses at the router, okay, because they are connected to the different networks. Okay, And of course, as we know, addresses like these are unique addresses. We cannot, there's only one unique IP address of this sort on the internet. However, in when we have non-routable address space, then we are able to share them. Okay, so that's how things are being done. Yeah. So in that picture, I said before. That we need to actually when your IP datagram arrives at this router, the IP datagram itself will not contain any information as for the destination IP address. So we need a way of telling the router here, hey, please send your, okay, let me clean up this picture. This is ugly. Okay. Hey, what happened? Okay, let me delete. Okay. Let's clean up this picture. Let me discard. I'll just make a new one. So much easier. Alright. Let's paint. Oh, you have a new one. Yeah, that's better. Okay, so previously we had a network A and a network B. Network A, network B, and it's connected to the internet. So okay, let's call this the internet very loosely. And we now know that network A has a router here, network B has a router here, and this this router has a public IP address. Okay, 12.1.2.1, a private address 192.168.76. So that's what we did. Okay, again, router. Okay, router public IP 12.1.1.1, B private address, so 192.168.76. So in this case, how do we tell the router to send the IP, your information to the correct computer on this network with this IP address, right? So previously we know that we used the source. We started by crafting an IP datagram with the source address of A's private address and router B's the public address, public IP address of this router, or the public IP address of this computer, which is the IP address of this router here, 12.1.1.1. So it starts from here to here. Okay, then when your IP datagram reaches this router will perform the network address translation. It will change the source IP address from this router here, or from this IP address here to this IP address here, which is router A's public IP, or computer A, or your computer's public IP address. And every computer on this network, or network A, will share this public IP address. Okay, so so initially we would have your computer and in network A send the message, craft the IP datagram such that the source IP address will be 192.168.76, and then the destination IP address will be this router here. Now when your IP datagram reaches this router, the source destination address will be changed from this IP address to the router's IP address, and then it will send a message through the internet. Once it reaches here, it will have the this router here in network B will have the will see that the destination IP address is 12.1.1.1, and then it needs to somehow forward the message to computer B, the computer on network B with the IP address 192.168.76. How does it know to do that? Okay, so like I said before, we need additional information. Need additional information to send packets. Okay, packets from the router to computer on network B. Okay, so to do that, what information do we need? Okay, so usually what is usually done is that something called the additional piece of information is something called the port number. Okay, so the port number is actually a 16-bit number, okay, which can go from 0 all the way up to, I don't know, 60,000 something. You can just check it out by 2 to the power 16, 65535. Okay, so it goes from 0. I think it's 0 to 65535. 65535. Now, where is the port number usually located? Okay, port numbers are usually located within the data payload of the IP datagram. So for your IP datagram, you will have your source address and network address here at the header of the IP. Then it will have a tail and a head coded in. So this is the data payload portion, and your port number will be inside the data payload portion. Okay, actually it is more specific than that. There is another layer. Okay, so it goes from 0 to 65535. Yeah, but the port number is actually part of another layer called the transport layer. Okay, we call this the transport layer. Okay, so we actually went through several layers of so-called connection or complexity in your IP, in your how do you say, in your network model. Okay, there are two. The one that you can learn from the video I shared, okay, the Google's crash course on IP addressing, that is called the 5-layer model. So when we talk about Ethernet, the Ethernet is actually part of the data link layer, because there's so much things going on. You have to actually separate things out by layer. When you talk about IP address, we call it the internet. Okay, we call it the, when you talk about IP addresses, we call this the internet networking. Okay, then of course the most basic is actually the physical layer, which I haven't discussed in detail, because that talks about translating voltage signals into zeros and ones. But that one, for day to day, we don't really interact with the physical layer, except when we like physically connect LAN cables and stuff. So not always the most useful, but good to know. But on a day-to-day basis, we don't think about it as much as the other layers. This next layer is called the transport layer, and the number or the address associated with it is the port number. Okay, so whenever you see port number, don't get too put off by it. It's just another address besides your MAC address, which is over here. Your MAC address will be in your data link layer. Yeah, your data link layer is concerned with MAC address. IP address is for networking. Port number or port address, or yeah, we just call it port number, is for the transport layer. So this port number will actually supply us enough information to forward information or forward data packets to our, let's see, where's the, yeah, it will provide us the information necessary to tell the router on B that I need to forward it to this IP address. Okay, so that's what the port number is for. So that when you mask up your IP addresses over the internet, or you share IP addresses over the internet, the port number gives us an additional way to specify which IP address to send over on the end, at the end, so that when replying, so that you can send the IP and IP datagram or your data packet from the router to the final computer. Now, as for port numbers and the transport layer, I have not talked about it in detail, but I won't do it in this video. Okay, so I hope this gives you a better picture of what's going on when you connect over the internet and why we share IP addresses. Thanks for watching.